Well, we study now the property of the logarithm. We have 8 important properties. I want to explain one by one, and we are using in the equations and the word problems. Okay, the first one is number 1. Logarithm of the any base, any. I call A, any number. Of 1 is equals 0. Wow, explanation of this. Suppose I convert this to the exponential. The base is A, the exponent is 0, equal 1. It's obvious, no? Because any number raised to the 0 power is always 1. Example to understand this: 2 to the 0 is 1, e to the 0 is 1, 10 to the 0 is 1. So any number raised to the 0 power is 1. This is equivalent to this. So you remember, logarithm of 1, automatically you put 0. Number 2, logarithm of the any base of the same number. So when they are perfect coincidence, and between the argument of the logarithm, que is the number inside the parentheses, and the base, que is a small number que indicate here, the answer is 1. So you, to understand it, you convert to the exponential. The base is A, the exponent is 1, is equal to A. It's obvious, right? For example, 2 to the 1 is 2. E to the 1 is E. 10 to the 1 is 10. Number 3 is, number 3 and number 4 are twin brothers. They are similar. For example, logarithm of the any base of the 1 exponential of the same base is equal x. The reason this is true is because we are doing the composition. Remember, composition, any function time is inverse. And you know very well that this is the identity function. In this particular example, we are doing the composition of the exponential function here inside and logarithm function outside. And the composition both is equal nothing because they are function como like undos each other. Make sense? Likewise, see, you are doing in opposite direction, inverse of f is exactly the same answer. So in this case, number 4 is the exponential first. Second. And logarithm first of the 8 to the x is equal x. One, easy interpretation of this, the person I don't like, is you cancel out this exponential and this logarithm. You cancel out this logarithm and this exponential. And the reason is clear, is because they are inverse function. Okay? I don't like it, you cross this. This is no aesthetical good to understand. Okay, now the property, next property is super important. In my opinion, is the most important. Property 5, property 6, and property 7. Let me try to explain. Property 5 says you have several logarithmic. Oh, no several, only one. Logarithm base A of the inside the argument you have two things, maybe expression or number. I want to call m time m. You can expand into logarithm like that of m plus logarithm A of m. Okay, you can using this property in both directions. Using this direction, if you want to expand, suppose we have one single logarithm, and inside we have different expression, multiplication, 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 and you expand in several, 1, 2, 3, 4, 5, depending on the expression you have. But in my opinion, the best way is doing in the opposite direction is condensing. If you have 1, 2, 3, 4, 5 logarithm and addition everything, we can condense in only one. Wow, fantastic this. But this is multiplication, the expression inside. So now let's see application in a few minutes of this property. Remember, we can use it as bilateral. We can use it in both directions. You use it like expand or condensing. CS division, suppose M divided by M, well, is subtraction. And C is multiplication, get the property 7. Suppose the property number 7 says logarithm of the any base. I suppose hypothetically always that the base is A. A is any number, no real number. It's an acceptable value for the base. Okay, you know that the base is positive, no 0, no 1. Entonces, suppose que you have in the argument you have M que represents expression number, and we have exponent R. And magically happen this exponent go to the front as a simple factor or multiple. It's a fantastic property because allow us the conversion from exponential to linear equation. You see now in the example, super clear. Okay, now we have another more, it's the last one, property. In my opinion, it's the most important. It's important and receive a specific name, que is change of base formula. Okay, it's a formula that allows us, because the supposition in any property 5, 6, 7, you suppose that the base is the same, que I call A. But suppose that it's different. So what should I do? Well, you apply this formula. The formula says, let me interpret it. Logarithm of base A of the one number hypothetical I want to call X is equal division logarithm of another base of the same number divided by logarithm of B of A. Let me translate more clear explanation of this. Okay, what is A? A is the original, the old base is given in the problem. And what is B? B is the new, okay, want to change, new base. One example to illustrate very well the importance and the efficiency of this formula is suppose that you need to compute logarithm base 3 of 81. Okay, this example we did before by hand, but no more by hand anymore. Let's do it by this formula. So 3 base is non-standard, because I know very well that the standard base is 10, que is common. Remember what kind of logarithm the base is 10, is indicate log, and no specification in this base. I suppose everyone in the world suppose that default is 10. And we have natural, okay, so other standard, natural, natural is base E is LM. So we can use it either way. After I want to show you in the calculator. For example, I do that computation. So suppose I don't know. So far from today, no excusing to hear that I don't know what is the logarithm of the one number, because we can do by hand something, not always, but always by calculator, using the famous chain of base formula. Let me try to do my best. You suppose that you're using that logarithm, because I lied, I don't know. The logarithm log of 81 is the same number. In this example, X is like 81 in my specific example, and A is 3. Entonces, divided by logarithm base 3. Likewise, some students say, no, well, okay, and we can use this? Of course we can use this. So this is equivalent 100% to ln 81 divided by ln of 3. Okay, by the way, we explained in the lecture before and the previous one way to compute this by hand, is logarithm base 3 of 81 is equal, I don't know, and you convert to exponential, and the base is 3, the exponent, no idea, equal 81, and we automatically, we convert my problem from logarithmic expression statement to exponential statement. Yeah, I know that 81 is 3 to the 4th power, therefore the conclusion is x equals 4. Now, with verification that this answer is correct, we do it by hand, but not always it's possible to do it by hand in another more complicated problem. And however, always it's possible to do it in that way, using the famous change of base formula. Let me want to show you in the calculator. Let me try to share the calculator. Okay, calculator. Where's calculator? My calculator is lost. Oh no, I don't know. Oh, there you go. Let me try to share calculator. Oh, there you go. There you go. Do you see the calculator? Oh, not yet. Do you see?
Yeah.
Let's do it using standard. Okay, Julio Rodriguez. Look, I go to the functions. Depending on the calculator, you need to master very well your own calculator. I'm using this because it's online, but of course, on my desk, I have 3 calculators. Yeah, I know very well how we are working. Suppose LOG. LOG of what? Of 81? I close the parenthesis division now, division. I go to the function again. LOG of 3. Okay, this calculator is not countable, but it's okay. Look at the answer, 4. Likewise, let's do it by natural. ln 81. I recommend doing by yourself and your own calculator now, using both expressions. Division ln of 3. Same answer. Did you see that?
Yes.
Okay, cool. Who say I? Okay. So let's apply this property. First of all, for solving any exponential equation, we cannot do in the elementary way. Let me show you. Okay. Whiteboard again. Do you see the whiteboard?
Yes.
Example. Okay, now we are studying solutions of the exponential equation in which we cannot, manipulate both sides in order to express it using the common base. I suppose that you remember very well. Suppose you have 2 to the x equals 4. This is super easy because I take advantage that 4 can express like a power 2. It's 2 to the 2nd power. Then x is 2 because we have 2 exponential and the exponent must be the same. But no, this is not the example I want to study. I want to study another hypothetical example in which you cannot do this. Suppose 3 or 5 or 7. Entonces now it's impossible express a 3 like a power of base 2. Now you apply logarithmic, both sides. What kind? Of course, standard. What kind? We have 2 standard, LOG or LN, either way. Why I apply in one example LOG, And another example, ln music is the same, it's equivalent. And finally, we end in calculator. If you apply logarithm, suppose que apply the common. Both sides. Okay, now in this moment, I apply the property 7. The property 7 say that the exponent magically fly outside, and you copy outside like a multiplier. Entonces, x logaritmo base 2 of equal logaritmo base 3. Unbelievable, but this equation is not exponential anymore. This is exponential equation. But this is not exponential equation. This is linear equation. Linear equation easy, like for example, 2x equal 3. Absolutely, it's not 2 and 3. It's logarithm 2 and logarithm 3, but this is possible a number that we put in the calculator if you want. So the easy way is you divide both sides by logarithm of 2. And my final answer is the logarithm base, logarithm common base, logarithm of 3 divided by logarithm of 2. Okay, cool. We finish. Well, almost, because this is the exact solution. This is the exact answer that you never know, you never want. The exact answer. Nobody understands very well this answer. However, I want the approximate. So now this is a crucial moment, and when you copy that in your own calculator, so calculator. Now, I would like everyone follow me. Try to do. Give me the answer of this. By convention, so far, in this kind of problem, we assume or we round off to the near 10,000, so 4 decimal place. 4 decimal places. Okay, let's try. I want to show you my calculator. You try to imitate in your own calculator the word, and the rest, I don't show you any more calculator, and we are doing my calculator I have in my hand right now. It's easy for me, and we compare your solution and my solution. Okay, let me try one more time. They're using the online calculator, no? Do you see? Do you see or no?
Yes.
Okay. Now remember, it was log3 for the functions. You try to find in your own calculator the key that corresponds with the function. Normally, the calculator you have in your hand is easier than this. You select logarithm of 3. Outside division, logarithm of 2. And the majority of the scenario, this answer is irrational. Irrational means it has infinity non-repeated decimal number. However, I want to truncate, so I want to copy. A ver. Sandra, okay, Sandra. I know, I just said when you get inside. It's 1.58496250. I copy every digit. I come back, guys, to the. Do you see the procedure? You get the same number in your own calculator right now, or no?
Yes.
Okay, this is part of the game. It's important for me that you learn how, because it's impossible to do it by hand. This is only using scientific calculator. I told you at the beginning, no? Okay. Now, let me try to explain this, the last part. And the calculator, Okay, I come back to the whiteboard again one more time. Okay. Okay. I try. Do you see whiteboard or not yet? Do you see or no? Yes or no?
Yes.
Yes. So the answer, I copy the answer now. I copy in one piece of paper. I recopy here. 1.58496250. However, I want 1, 2, 3, 4 decimal place, suppose. It's a convention in that part. And you see that digit after the 4, okay, 6. See, it's greater than or equal 5, increasing this plus 1. So actually, my final answer is 1.5850, no? Because it's 49 plus 1. Cool? Do you understand? Do you understand or no?
Yes.
Yes.
Okay, let's practice. Let's practice now. Let's practice solution of that kind of equation. May I erase the board or not yet? May I?
Yes.
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 Okay, example 2 now. A little bit more complicated. Not too much, but a little bit. Okay, it's 5. 2 to the 3x equal 8. Okay, let's do it. This is another weird equation, exponential equation, that we cannot manipulate using the same base. Maybe a yes, because a is 2 to the third power. However, 5 no. You see, at least one is no, so we cannot do anything. Therefore, we can solving using the same strategy. So you apply logarithm on both sides. But before that, I recommend that you isolate the exponential part. Stay alone. So it's 2 to the 3x equal a over 5. Okay, ready. Now you are ready to apply logarithm on both sides. In this case, I want to apply natural. Maybe you don't like natural, but it's the same. It's the same, guy. Either way, you're using the logarithm that you prefer. And the calculator is the same. So this expression is equal to the logarithm of this expression. I don't care if it's a fraction, I don't care this. Now, one more time, you apply the property 7, que fantastic. And this exponent, 3x, go to the front as a factor. 3x logarithm of 2 is equal to logarithm of a over 5. Wow, this is a linear equation, and the x alone, so for x, you divide both sides by 3 and logarithm of 2. Okay, one more time, we have the exact solution, but nobody wants this answer. I need to find the approximation, but I propose one idea, first of all. I apply one more time the property 7, but in opposite direction. This is not strictly necessary, but I like. For example, this factor, you put it like exponent one more time. Entonces, basically, es logaritmo of a over 5 divided by logarithm of 2 to the third power, pero es que 2 to the third power is 8. Entonces, logarithm of a over 5 divided by logarithm of a. And unfortunately, we cannot simplification or anything. No. You put in your own calculator right now, exactly the same like that. I want to do in my own calculator. Come on, I am doing that. Natural logarithm, parenthesis, and you press in your own calculator the key LM, automatically the calculator open one first parenthesis. And you put a over 5, and you close the parenthesis. I did the top part. Division now. Again, natural logarithm of 8. Close the parenthesis, press enter, bang, I get the answer. And the answer is 0.226 Wow, 684. Remember, any calculator have different approximation. Not necessarily exactly they are perfect coincidence, because some calculator setting with the a port maybe 10 digit or 8 digit or 9 digit, but I want only 4. I want only 4. Guess 1, 2, 3, and 4. See, the next digit is less than 5. No increasing anything. Is the answer is 0.2260. This is my final answer. You get the same answer like me or no? Yes or no? Question.
No, I got something.
You get the same answer like me?
No, I
Yes.
had 0.1085
Repeat again. You get 0.1.
1.
No, it's wrong. Totally wrong. Totally wrong. Totally wrong. Repeat again the operation. Do you want I do for you in my online calculator?
Yes, please.
Okay. It's exactly the same you need to say. Okay, let me try it. Let me try. This is important for me, that you know how we compute this in the on calculator. Entonces, switching to window. You see my calculator now or no? Not yet.
Yes, now.
Okay, cool. Entonces es, let me try. Okay, I press this. You type in logarithmic. I suppose I use a natural, right? Doesn't matter. Natural logarithm a over 5. A over 5. Sandra. A over 5. This is important. You put division inside the parentheses. And you go outside the parentheses. And now you divide by division by natural logarithm of a, no? It's 8, no? I am doing well or no? 8. Bam, look at that. 0.22260239684. Repeat again, miss. And that way, maybe you put the wrong parentheses.
Yes, now I got the right answer.
Super.
Thank you.
Any question? Everyone follow me or no? Let me try to show you whiteboard. Do you see my whiteboard now or not yet?
Yes.
Okay, I want to raise the board. I need a space to do one long complicated problem. Example 3. Example 3 is 0.3 raised to the 1 plus x is equal 1.7 raised to the 2x minus 1. Wow, this is totally crazy, because we have one exponential equation, one base of the first exponential is 0.3, wow, and the other is 1.7. It's impossible doing by the traditional way, que you manipulate both sides. No manipulate. You apply logarithm both sides and end the story. You apply logarithm, in this case, both exponentials are totally isolated. This is ready to apply logarithm both sides. Natural or log. What do you prefer, guys? Natural or log? I am doing the way that you propose me. But it's the same. This is totally irrelevant. You get the same answer using natural or using this. Okay, 0.3 raised to the 1 plus x is equal natural.
On the whiteboard, still showing the calculator.
Oh, okay, okay. I suppose que we switch. I switching, pero no. You say que no. Switching. Whiteboard. Let me know now, mister. Not yet?
No, still on the calculator.
Okay. Sometimes happen I need to.
Now it's up.
You see now?
Yes.
Okay, cool. Wow. Okay, I don't do anything. It was just delayed. Because suppose I did that. So you apply, okay. Beginning. This is my equation, example 3. And example 3, I realized, wow, this is horrible. Because we have 2 exponential and totally different base, it's impossible to manipulate both sides in order to get the same base. No, this is a classical example in which you apply logarithm. I make a decision, apply natural. Actually, it's a standard. Maybe natural or maybe common. Both sides. And one more time, using the property number 7, to allow me any exponent, this exponent, and this exponent fly outside the expression and become like a multiplier, no exponent anymore. Entonces 1 plus x, be careful with the parentheses, times ln 0.3 is equal 2x minus 1 parenthesis because it's binomial, no? Entonces you put a parenthesis, multiply by logarithm of 1.7. Everyone follow me so far?
Yeah.
Yes.
Go ahead. Yes, everyone say yes. But what is my goal? My goal is solve for x. 4x. I need to manipulate, pero manipulate like a linear equation. So you apply distributive, why not? You multiply 1 times this logarithm is logarithm of 0.3 plus x times logarithm of 0.3. X times logarithm of 0.3. Equal. And the right hand side, similar. 2x times logarithm of 1.7. 2x times logarithm of 1.7 minus logarithm of 1.7. I prefer, guys, using the parentheses to enclose. So normally in some book or in some paper, everyone understands very well you see logarithm of 2. But totally strong, rigorously is logarithm base 2 because it's a function, no notation. It's f of x. Nobody write like that, f of x. But it's okay. Everyone understand that way. Okay. Now, in order to isolate the x, I propose you, this guy stay here. This no, I move to the right-hand side. So it's 2x stay, I bring down logarithm 1.7. Now I move minus x logarithm 0.3, this was this guy. Okay, move to the right hand side with the opposite sign, okay, minus. And likewise, this I move to the left like a positive logarithm 1.7. Okay, cool. Almost I finish. And now I see in the right hand side that x is common factor. I factor out. Another parenthesis, get this. E, of course, I bring down this expression in the left hand side. Okay, nice. Almost I finish. Now the only thing you should do is divide both sides. Divide both sides by this expression, gets 2 ln 1.7 minus ln 0.3. Both sides. 2 ln 1.7 minus ln 0.3. And of course, at the right hand side, you have only x, because exactly I want, and you have this complicated expression, but I want to simplification. Don't worry too much for this, because I want to simplification. How we can simplification? Well, I propose you, I just copy using the property of the logarithm. What property? We're using the property number 5 here because it's plus. Yeah, I know that when it's plus, the answer is you can condense it, these two logarithmic in only one, que es the multiplication 0.3 times 1.7. Entonces I do in my calculator. 0.3 times 1.7, the answer is 0.51. So this is equivalent in only one single. You see the beauty of this? It's fantastic for this. This and this together, multiplication, in only one single. Sorry. Entonces now in the bottom, more complicated. I'm using property 6 because of subtraction, and property 7 because we have a factor here. Actually, si you condense in only one logarithm, el logarithm of 1.7 squared, these two go to the exponent here, divided by 0.3. And this is the new argument of this logarithm. Okay, if you want, we can put it separately. 1.7 squared divided by 0.3. And the answer is, let me try to do my best, logarithm of 0.51 divided by logarithm of 9.63 repeated. This idea. And this is the answer. Oh, but if you want to compute approximate answer, now calculate. Come on, guys, everyone working with the calculator, and I don't want to anticipate the answer. You try to do the verification that you are doing well or not. Suppose is natural logarithm of 21, 0.51, sorry, 0.51 divided by natural logarithm of 1.7 squared divided by 0.3. Get the same I did before. Let me check in my piece of paper. ID in the calculator now. Cool, I got it. Come on, but I waited for you. What is the answer did you get? Then your own calculator.
Negative 0.297297690.9.
Super. You are the best. 725222699. Check it out. See you get the same answer like me. Because remember, the calculator, different calculator offer not exactly 100% equal. It's the same digit you get in your calculator, mister?
That's close.
Remember, we need 4 decimal places. 1, 2, 3, and 4. And this is 5 increases. So the answer is minus 0.2973. Okay, something weird. Why is negative? The answer. Remember the contradiction. In this case, remember the base of this logarithm is e. And you need to remember that e is 2.718 something. Pam, irrational number. See, this number is less than 1 and the base no, so this logarithm is negative. The top part is negative. But the bottom part is positive because it's e and 9 point something is greater than 1. and negative divided by positive, of course the answer is negative. You don't need to know that, but this is one, you know, idea to understand why it's negative, the answer. Any question, guy? No? Well, let me complicate a little bit more. Not too much, but a little bit. Suppose this equation, 4 to the x minus 10, and U2, they are competitions of these equations, because the equation is sine features. Of course, I never put sine feature in the test, I put the regular. Suppose this. Entonces ahí hizo, wow, what the hell, what the hell. Entonces, negative exponent, I don't like negative exponent. Negative exponent no good for me. Entonces, okay, entonces I propose you multiply. In order to eliminate negative exponent, you multiply whole thing, the entire equation, by 4 to the x. You multiply 4 to the x times 4 to the x, que es the first guy, is 4 to the x squared, no? Minus 10, and 4 to the x times 4 to the minus x, this is 1. How do you know, professor, que 1? Because 4 to the x times 4 to the minus x is 4 to the x minus x is 0. Any number raised to the 0 is 1. And this is invisible 1. If you want, you can delete. Now, I need to multiply everything. Is equal 3 times 4 to the x. So far, everyone follow me? Or no?
Yes.
Okay, let's continue. Now, I know very well that when you have different level of the exponent, it's multiplication. So 4 to the x squared. No, leave it like that. Leave it like that. Square. But I realize also that this ending, I suppose, in quadratic equation, or quadratic, no equation, quadratic info. Remember, we studied in the first chapter one equation that we have one expression square, and another expression not square, and you call u. You remember that? And this is u squared, and this is u, and you convert to quadratic. So actually, this equation is not quadratic. This equation is exponential. However, I can transform it to quadratic equation using u substitution. How? You copy now minus 3 times 4 to the x minus 10 equals 0. So you put in a standard, you move everything to the left, and you declare u substitution equal 4 to the x. And when you rewrite the new equation using the auxiliary new variable, que es u, this is minus 3u, and this is u squared. Wow, and this is super easy. And this is a quadratic equation that we can solve it by quadratic formula. Oh, no. By factorization, I suppose it's better. u, and the combination is 5 and 2, because 5 times 2 is 10, and 5 minus 2 is 3, and the signs are negative and positive. Do you follow me? Okay, now apply one more time the zero factor property, u is 5, and u is negative 2. And is the answer? Of course, no. Because I need to solve for x. You was my friend. Can help me convert this complicated equation, and one easy equation. Get this. However, there are connection between u and x is this. So basically, I copy no u anymore. I copy 4 to the x equal 5, and 4 to the x equal minus 2. Okay. So in this moment, I have two separately exponential equations. But easy exponential equation, not complicated like we have at the beginning. And you apply the thing that you know very well. Suppose now that you 5 and 4 is impossible, express it in common base. No. Entonces the professor explained me que the fantastic way is apply logarithm both sides. What kind standard. Let me try this first. And this is secondly. One more time, you apply the property 7. Que allow me this x go to the front. Entonces x is equal logarithm of 5 divided by logarithm of 4. Bam! Exact solution, but I never want this. I need approximation. I put it in my calculator. Who help me? Come on. Participation, everyone. I suppose that everyone try to do in your own calculator. So you have no you don't get the answer like me exactly. So I show you in the online calculator how is the organization. Come on, do it.
I got 1.160964047.
Exactly, I get that. However, I don't copy because I need, remember, 4 decimal approximation, 1, 2, 3, and 4. Actually, 1.1610. Boom, and this is my first solution. Let's move into the second solution. Second solution, we're doing exactly the same. Is you apply natural logarithm both sides or whatever you want. Natural 4x equal natural -2. One more time, the x go outside. So we have x natural logarithm of 4, natural logarithm of -2. Therefore, x alone is natural logarithm of -2 divided by natural logarithm of 4. Entonces, in this moment, stop. Why stop? Because I know very well. If you don't know, no problema. Because the calculator explained very well this idea. Logarithm of the negative number, guys, is totally undefined. Impossible. When you put in a calculator this, you obtain undefined. You remember the domain for the logarithm function is only positive number and no zero. No zero, no negative, only positive. You see, logarithm of -2 is impossible. It's totally undefined. Therefore, that part do not apport any solution. And the only solution, bam, is this guy. No solution. No solution, that part. But the solution for the entire equation that we studied at the beginning is 1.1610. Do you see that? We go over again in the review package. So remember, next time I suppose we start doing the review package. No question? May I erase the board?
Yes.
Okay, super. I want to change something. I want to study now logarithmic equation. Logarithmic equation. Totally different idea. We study now. Let me type in my keyboard. It's similar, no, not exactly, but it's equations que contain logarithmic, of course. Exponential no is just exponential. Logarithmic is when you have at least one logarithm. Okay. This is the new topic. Important. 3 important. Logarithmic equations. Okay. What should I do? Let's see example 1. I bring a lot of example. Example 1. Example 1 is logarithm by 3 of x plus logarithm by 3 again of x minus 24 equals 1. This is the example. Okay, so the procedure is always the same. Keep in mind, step 1. Step 1 is always condensing. Condensing who? Condensing several logarithms. In this case, you have only 2, and only one single log. And you apply, in this case, the property number 5. It's the property que es fantastic when it's plus and multiplication. Entonces, logarithm by 3, only one time, because you condense this and this, and only one. And inside the argument, you have x times x minus 24. And this operation is time, multiplication. Anyone follow me?
Yes.
Okay. Step 2 is mandatory, guy. You are doing that way in the test. You put the arrow and you indicate on the arrow 2 exponential. What is the idea? The idea is convert to exponential. So actually, we have logarithm statement, but to see more clear, we convert to exponential. And you see something magic happening. So remember the idea for the conversion is the base is 3. You ask by yourself, what is the base? What is the base? The base is 3. And this is small trick you have here, you put the big one. What is the exponent? The exponent is the answer of the logarithm of 4. And what is the result? The result is the expression is x minus 24. And this is my exponential statement. But this is easy because 3 to the 4 power is multiplication 3 times 3 times 3 times 3, 4 times is 81. And you apply this 3 with the property y now x squared minus 24x. And you realize in that moment, wow, this is quadratic equation, professor. Okay, if this quadratic equation I write in standard. Entonces en estándar es x squared minus 24x minus 81 equals 0. Remember, in standard, right hand side must be 0, and you organize A, B, C, and descending order of the degree. Degree 2, degree 1, degree 0. Okay, entonces we have in that moment solution of the quadratic. And that's it. No, that's it, no. But this is the step 3. Can you solve the exponential equation? Okay, in this case is easy. Well, actually, it's quadratic equation. So now maybe factorization, no good. Maybe yes, but no. Suppose that you don't see the combination because it's too complicated. No. I apply the quadratic formula. A1, B is negative 24, and C is negative 81. Plugging in into the formula. Minus B plus or minus square root B squared minus 4AC divided by 2A. Replace. Plugging in. Okay, entonces actually is minus B, pero you have double minus, no? Minus of the formula, minus of the B together become positive 24. Plus and minus. Square roots. Inside we have minus 24 squared. Okay, computer using the calculator, of course. Minus 4 multiplication by 1 because A is 1 and C is negative 81. Be careful with the signs. Be careful. Divided by 2 times. Let's say put in my calculator right now. Minus 24 squared. Okay, I know it's positive because any number, negative number squared becomes positive. Is 576. Now be careful. We have double negative. Negative and negative become positive. Positive something. Positive 4 times 1 gets 4. Because 4 times 81. 81 times 4 is 324. Don't forget that we have a square root here, right? Now you adding 576 plus it's a 900. Oh, cool. I like that. And the square root 930. So far we have 24 plus or minus 30 divided by 2. As always, I put in two different ways. I put 24 plus 30 over 2 and 24 minus 30 over 2. And we compute separately. This is 54. This is 2. This is 27. And this is my first potential solution. Be careful. The logarithmic equations are picky. The logarithmic equation is not exponential. Exponential is nice. Exponential, any answer that you get is correct. Because remember, domain of the exponential function is already a number. However, the domain of the logarithm is positive number, no negative, no zero. So any answer gets 0 or is negative doesn't work. You need to replace double checking in the original equation. But let's do it. Let's do it. This is minus 6 divided by 2 is minus 3. Okay, and this is my collection of the potential solution, but you have to mandatory, so you are doing this, not the checking, you have 0 on the test, okay? You check in 27 and you check in negative 3 and the original equation. What is the original equation? That one. I check it for 27. Logarithm by 3 of 27 plus logarithm by 3 of 27 minus 24 should be, claim that, 4. Well, it's easy because you can use intuition or you can use in the formula for the chain of base. You put in the calculator, but this is obvious 3, no? Remember, the intuition for the exponent, the logarithm is what is the exponent? You raise 3 in order to get 27. I know very well that 3 to the third power is 27. Exactly the thing we are looking for is that 3. Entonces, this is 1 because 27 minus 24 is 3. And what is the exponent 3? To get 3 is obvious as well. And 3 plus 1 is 4. Okay, I got it. This answer works. However, the other, no, because it's negative 3. When you put negative 3 here, wow, undefined. Negative 3, undefined, plus, I don't finish to write the rest. I use C negative, no solution. So the only solution that we have in this equation is 27. Do you understand very well, guys? No, confusing. Mandatory. In any logarithmic equation, you have to check it. The reason is clear. The exponential equation is nice, logarithm no, it's picky. And you need to verification. And the logarithm do not accept negative number, no 0. Neither negative nor 0, only positive. Example 2. Everyone follow me? Come on, question. I know that you are doing too fast, but you correct me, no? I always go press the acceleration pedal, but you have some questions, you let me know. No? Okay. I have 1, 2, 3, and 4 examples. It's okay. 4 examples is enough. Okay, 4. The second is easy. Okay, remember the step by step. You have in this example 2 logarithm base 2. Normally it's giving non-standard base. Sometimes no. 3x minus 2 minus logarithm base 2 of x minus 5. equal 4 again. Oh, it's a coincidence. And remember, what is the step one? I don't remember. The step one is always the same. Is condensing. So we have two logarithms, and I need to condense in only one. And we use what property? 5, 6, or 7. You remember the property? Remember what we have 6. Property number 5 is when it's plus. And when it's plus, it's multiplication. M times M. When it's minus, it's division. It's M divided by M. It's a property 5, and it's a property 6. And the property 7 is easy. It's when you have M to the R. Exponent go to the front. But in this case, no, we have no exponent. It's no subtraction, and you condensing these two logarithms, this and this, and only one. Of division 3x minus 2 over x minus 5. It's important to understand that the positive guys stay in the top and the negative go to the bottom. Do you follow me?
Yes. Yes.
Okay, so this is the step one. Always condensing. You have 2, you have 3, you have 4, you have 5. Only one. What is the next step? The second. Oh, convert to exponential. Because in the logarithm it's confusing for me. I have no idea. So what should I do? You put an arrow. You put conversion to exponential. I understand very well the thinking we're doing. And remember, the base is 2. I put the big 2. The exponent is 4. This is a small 4. Equal the rest, que es 3x minus 2 over x minus 5. Okay, and 2 to the 4 power is 2 times 2 times 2 times 2, 4 times gets 16. And my equation so far is 16 equal 3x minus 2 over x minus 5. Oh, it's easy equation. You consider like a proportion and you apply cross multiply. Entonces you multiply who? You multiply 16 times x minus 5 equal 1 time, but 1 is invisible, you know, 3x minus 2. And you apply this derivative now, it's 16x minus 80, so 16 times 5 is 80, equal 3x minus 2. Okay, so for x, easy. 16x minus 3x is equal 80 positive minus 2. This is 13. This is 78. Divided by 13 both sides. Oh, it's 6. You put in the calculator. 6. And that's it. I need to check it. See if the solution works or doesn't work. In this case, we have only one solution, no? But in this equation, you see in the review package, okay, sometimes we have two solutions and the solution is good, both one solution or two solutions, but only one is good. Or sometimes happen, very weird, but happen, if we have two solutions and no word to say no solution. So remember, the logarithm equation are picky. I need to compute logarithm of base 2 of 3 times 6. It's multiplication, sorry. So you replace x for 6. 3 times 6 minus 2 minus logarithm base 2 of 6 minus 5 should be, I verify this statement, equal 4. Okay, 3 times 6 is 18. 18 minus 2 is 16. And logarithm base 2 of 16 obviously is 4. Remember the intuition. Of course, you can use a calculator and apply the chain of base formula, no? But in this case, it's super easy. What is the exponent necessary to raise 2 in order to get 16? I know very well that 2 to the 4 power is 16. So the answer of the logarithm is 4. Minus logarithm base 2 of 1, because 6 minus 5 is 1. Y I know in the property number 1 que we studied today que el logaritmo 1 es 0. And 4 minus 0 is equal to 4. Wow, it's okay. Cool. Therefore, this solution is perfect. And the solution for this equation is 6. I double check. See, I don't see double checking, guys. I put 0 on the test. Solution and double checking. Mandatory. And the logarithmic. And the exponential. Exponential is nice. Everyone follow me in the example 2?
Yes.
Yes.
Let's move into example 3. We have 4 examples, and that's it. And let's move into the word problem, guys. Word problems. Aish. Well, okay. I forgot something. Well, okay. It's okay. Example 3. Example 3. Okay. The example 3 says, logarithm base 14 of x plus 5 equal 1 minus logarithm base 14 of x. Okay, so I remember that the professor explained me that the step 1 is condensing, but in this case, impossible because one logarithm is located in the left right hand side and another is located in the right hand side, but this is no problem with me because I move and that's it. So I move, for example, this stay here plus logarithm base 14 of x equal 1. That makes sense, right? Now ready to condensing using the property number 5 one more time because it's plus. So logarithm base 14 of the multiplication x times x plus 5 inside the argument of the logarithm should be 1. Time. It's a period. It's a time. Now we convert to exponential. I'm doing too fast, guys, because it's the same routine. The base is 14, the exponent is 1. The base is 14, the exponent is 1. X equals x times x plus 5. 14 to the 1 is just 14. And now you apply distributing. X squared plus 5x. I suppose, wow, it's a quadratic equation. One more time. That's the reason that the professor explained at the beginning that quadratic equation is very, very important in this subject. Entonces now I put in a standard. In a standard would be x squared plus 5x minus 14 equals 0. Well, in that case, we can apply the quadratic formula, but no. I prefer factorization because I saw the combination. The combination is 7 and 2. Because 7 times 2 is 14, and 7 minus 2 is 5. Positive 7 and negative 2. Therefore, one solution is negative 7, another solution is positive 2. Okay, cool. But I need to verify, as always, in the logarithmic equation. I suppose that the negative solution is not good, because when you plug in negative 7 here, obviously to be undefined. Remember, one more time, I repeat, logarithms do not accept negative number inside the domain. But do maybe, I don't know. Let me check it too. So I plug in the original. Logarithm base 14 of the 2 plus 5 should be equal. Remember, I plug in the original 1 minus logarithm base 14 of 2. Well, 2 plus 5 is 7. That idea is clear. Logarithm base 14 of 7. I propose you move one more time this logarithm to the other side plus logarithm base 14 of 2 should be 1. And now I know property number 5, condensing this and this together. Logarithm base 14 and only 1, and the multiplication 7 times 2 gets 14. Wow, amazing. And you know very well that when this number is a coincidence, property number 2 of the logarithm of the answer is 1. Wow, okay, therefore the answer 2 is perfect. And the only solution that we have in this problem is x equal to. Cool?
Yep.
I have another example, and that's it. And that's it for that part. No? We continue the application, the word problem. Okay, let me try. Let me try. Example 4, no? Example 4. Example 4. Example 4 say, logarithmic of 3 plus x minus logarithm of x minus 3 is equal logarithm of 3. Wow, professor, this is weird. Weird for two reasons. Reason number one, I don't see the specification of the base here, here, and here. What happened when this situation happened? What is the idea? You need to understand this. When you do not specification the base, it's because no idea.
It's 10.
It's 10. It's 10 because it's common. It's 10. Good for you. It's 10. Now you see 3 logarithms in this equation, and you explain it only 2, professor. What should I do when there's 3? You condense it in only 1? No. You condensing these 2 in the left-hand side. So you take this left-hand side, condense it in only 1. Que es logaritmo of, this is minus, y es minus of property 6, es division. Entonces es 3 plus x divided by x minus 3. Let me copy it like this, plus. This is the argument of this. And the other side we have logarithm of base 3. In the right hand side you condense it. Well, in this case not necessarily condense it because we have only 1. Entonces, crucial moment. This situation happens similar to the thing we are doing before. We have 2 logarithm function. Same base, therefore the argument would be the same. So 3 plus x over x minus 3 is equal to 3. So disappear the logarithm. Because logarithm is a 1-to-1 function, so one value inside the domain indicate me only one value in the range. No problem. Now to solve this equation, it's easy, cross multiply one more time. You consider like a proportion, you multiply this time 1 and this time 2. The 3 plus x is equal time 1, it is nothing. 3 times x minus 2. Okay. It's a linear equation. This is a piece of cake for me. For you, you are distributing property here, 3 plus x is equal to 3x minus 9. Solve for x. So I propose you move. These 3 stay maybe plus 9 equal 3x minus x. This is the organization. Not only in that way, but also one possibility. This is 12 and this is 2. Divided by 2 both sides, so we get 6. I need to verify, of course, always, you have to. To verify in the original equation, I need to prove somehow that log of 3 plus 6 minus log 6 minus 3 should be claim that statement logarithm of 3. This is relatively easy because this is logarithm of 9. 3 plus 6 is 9 minus logarithm of base 6 minus 3 is 3. And one more time, I apply the property number 6 because of subtraction. And this is you condensing, only one gets 9 over 3. Oh, and 9 over 3 is 3. It's exactly the same as this. Okay, and this solution is perfect. And this is the answer that we are waiting for this equation. Super. Super or no?
Yes.
Yes. Cool. Now I go to the application of this. Application of this. We study application in finance, money, application in biology, application in physics, application in chemistry, okay, and application in different subjects, exponential logarithmic, okay. Entonces, en finance, money, we study the formula for the compound interest. Compound interest. What is the idea in this? You have a money, initial money now, okay, I want to call P. P is a present value. Present value. It's the money that you have right now. And this money you deposit in one bank account or in any investment, not necessarily bank account. And si you never withdraw the money increasing. Increasing to the one value that I want to call future value. Future value. And this increasing according to the interest rate. Okay, we want to call R. Who is R? Interest rate. Okay, normally is expressed like an annual percent rate, APR, in percentage. 5%, 3%, 1%. And T is the time. Okay, you hold the money in the bank account and never withdraw. And the time always is expressed in years. So what is the formula? Well, we have one component more in the formula, que is the compounding. Because it's compound interest. The compounding is one number, que normally is called M, que M is equal 1 if the account is annually. What mean that? What mean in 1 year, this segment indicate 1 year, 0, 1 year. We have no transaction in the account. So no withdrawal, no increase in the money. But you have another possibility that is N equal to 2, the sum annually. What means sum annually? In 6 months or 1.5 years, you are doing some money and you have used money. So basically the compounding is the amount of transaction in 1 year. Then we have different. We have theoretical, we have semi-annually, we have quarterly, CS N equal 4, quarterly. We have monthly, is 12. And this is mathematical, no bank using this, but this is theoretical. Monthly, weekly get 52, because you know, in 1 year we have 12 months, and in 1 year we have 52 weeks. And daily is 365. It's daily. So what is the connection between these parameters? P, A, R, T, and M. Is that formula. That formula. A is equal to capital P. Parenthesis 1 plus R over M raised to the n-th. Bang. This is my first one. Of course, you don't need to memorize this. You have in the piece of paper and you apply the formula. We are doing several problems with this to practice. This is the formula in which you have the future value. However, the same formula, we can express it using present value. So you isolate P, no A, P. The formula is a little bit different. It's A over 1 plus R over M raised to the n-th. It's the same formula, but you isolate P. And literal equation, you isolate P. This is the formula I want to call present value because the present value is isolated, waiting for me to plug it in. Present value. And that's it. No, unfortunately, no. We have another possibility. So this is when you have a discrete. What means discrete? Discrete is that my money increasing like stairs, like that. Suppose I have present value, increasing like a stair. And the step of the step depending on the compounding, annually, semi-annually. This is discrete. However, we have continuous. And where you have no information about the compounding and you suppose case infinity, that my money increasing always. Now the exponential is continuous. So the formula is a little bit different, but not too much. The formula for the future value, when it's continuous, que cuando n compounding is infinity, is equal present value. This part is similar, but this transformed to the e to the rt. Okay. Future value and present value similar. P is equal. Let me put it in a more elegant way. A e to the minus rt. Remember, one more time. I repeat: negative exponent and reciprocal. Now you can write like that if you want. P is equal A divided by e to the rt. But in my opinion, it's more elegant express it like that using negative exponent. This is present value, discrete continuous, future value, discrete continuous. Let's practice now. I bring example. Let's practice. Well, I forgot to do something, but I try to do in the middle of the process. I have a PowerPoint. I can share the screen of the PowerPoint. Oh no, much better for me is to make the screenshot. I'm putting the whiteboard, no? Let me try to do my best, as always. Okay, let me try to find the PowerPoint of the word problems. PowerPoint, where is my folder of the PowerPoint? There you go, I found. And now it's application logarithmic. Okay, application logarithmic. Logarithmic and exponential. Cool. I have that. Now I make a screenshot of this. Okay, there you go. Compound interest. Okay, and this is my problem. I want to save in the same folder of the subject. That one. I want to call P1, problem 1. In the keyboard, sorry. I have two keyboards to stay confusing. P1. P1. Okay, I save. I close. I go to the whiteboard. I suppose you continue to see the whiteboard, right? Now I click here. I get image, my device. P1 is the name I call. P1. I got it. Do you see my word problem?
Yes.
Yes.
Excellent. Let me read. Let me try to understand. Let me try to define who is P, who is A, who is R, who is M, who is T, and compute the thing they want. So if $10,000 is invested in an account at 3% APR, compounding quarterly, how much money will be in the account in 5 years if no money is withdrawn? Entonces I need help. Who is P? Present value.
10,000. 10,000.
Absolutely perfect. Who is interest rate? R. Interest rate. 3%. But important, 3 important. You never use it into the formula in percentage. You use it in decimal. You divide by 100, que is equivalent to 0.03, and it represents 3%. So in the formula, never you put 3. You put 0.03. What mean quarterly? What is M? Compounding?
4.
4. And what about T? What's the time?
5.
5 years. Now, what should I do? Compute A, future value. I copy my formula. A is equal to P, parenthesis, 1 plus R over N, raised to the NT. Let me try substitution. P is 10,000. 1 plus R is 0.03 divided by 4, no? Because N is 4. And the exponent is the multiplication N times T. N is 4, T is 5, and multiplication 4 times 5 is 20. The exponent is 20. And the rest is, please, you put in a calculator. I try to do it in my own calculator. And you compare your answer and my answer. Put 10,000, multiplication, parenthesis, 1 plus 0.03 divided by 4, close the parenthesis, power 20. Boom, I get the answer. Tell me, what answer do you see? See, they are not coincident, your answer and my answer. I want to do in the online calculator. You see the process. Somebody get the answer or not yet?
11,007.84.
Right. 84. It's 11,611 dollars and 84 cents. Remember, you truncate or round off cent because we are talking about money. This is the answer. You get the same answer, mister? Yes or no?
Yeah.
Excellent. Everyone follow me? Everyone understand? What's easy, eh?
Yes.
Okay, we practice a lot in the review package. But I want to do at least 2 more examples. No, I change a little bit the flavor. Not exactly the same. Let me try to go to the PowerPoint again. Let me make another screenshot. A screenshot of the second problem of the compound interest one more time. It's similar. It's the same formula, but with different objective. And I call P2. Problem 2. Okay, I save. Okay, I go back again to the whiteboard and you select now the picture P2. There you go, I found. Do you see the problem? Do you see or no? Do you see or no?
Yes.
Yeah.
Yes.
Okay, let me try to read carefully and understand and separate who is P, who is A, who is N, who is T, who is R, Okay, John want to buy $30,000 car. He has saved only 27,000. Find the number of years he will take. He will take for his 27,000 to grow to 30,000 at 4% APR compounding quarter. Wow, wow, wow. Okay, entonces, who is present value? Who is future value? Who is P?
27,000.
27.
27. Very well. And who is A?
30,000.
Exactly. The money que you want to have in the future. Now, what is R? Interest rate in the account. Because he deposits the money in one bank account. F4, no? F4 is 0.04. Remember, never use present percent in the equation. Use present in divided by by 1. So you divide by 100. Okay, you convert this percentage, to decimal. And compounding is M is 4, no? Quarterly again. And one more thing we need in the formula. We need P, we need A, we need R, we need A. We don't know T, no? T is the thing that I am trying to looking for, no? T is how many years you need to wait to this money in growth from this to this. Make sense? Make sense?
Yes.
Yes.
Now, I'm using the same formula. A is equal P, parentheses, 1 plus R over N, raised to the NT. Substitution. The value of the number we have in my problem. So A is 30,000. P is 27. 1 is 1. R is 0.04 divided by 4. And N is 4 and T, no idea. Okay, not bad, because in this moment we have the exponential equation. So the unknown, my unknown is T, and T is located in the exponent part. No problema. I am strong, and we are strong solving exponential equation. Let's do it our best. Okay, first of all, you divide both sides by 27,000. Because I want to eliminate this big number, no? And this is just 1. But this is cancel out, boom, 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 at least 3 0. And cancel out a little bit more, but it's okay. 30 over 27 is equal. And the right hand side I can manipulate a little bit, because 0.04 divided by 4 is 0.01. And 0.01 plus 1, don't forget this is 1.01 raised to the 40. Ooh, more clear this equation. At least for me now, 1.0140. Do you understand the transformation? Exactly, this is the equation that we solving by application logarithmic. Maybe log or ln standard. You put in the calculator 30 over 27. By the way, if you want, you reduce the lower term, big guy, because this 30 divided by 27, at least divided by 3 is 10, and divided by 3 is 9. It's okay. Either way, it's 10 over 9. Entonces now apply one more time the property 7, que is magic. And this 40, go to the front, like a 40. Multiplication logarithm base 1.01. Wow. Now, T alone is equal, you divide both sides by 4, logarithm 1.01. Actually, we have logarithm 10 over 9 divided by 4 times logarithm of 1.01. And you put in the calculator right now. And computation, and remember, the answer in this formula always is expressed in years. This is decimal. You approximate, you know. Entonces es, you put log or natural, either one, 10 over 9, divided by, parentheses, 4 times. It's important when you have two elements. And the denominator, you put a parenthesis. Because you don't put the parenthesis, the calculator don't understand very well your order of operations. Time, logarithm of 1.01 and close 0.01. I make a mistake. 1.01. Close two parentheses, no? I close these parentheses and close this parenthesis. I open this parenthesis. Let me try to do my best. Choom. I get the answer. I get the answer. Please help me. I get the answer.
2.6.
Super good. You are good, mister. 2.664, no? 47. No, but it's okay. It's a time. So now I propose you trunk like that. It's 2 years. 2.5 years. It's in between 2 and 3 years. This is years. Wow. The time is over, no? Okay, we continue. Don't worry for this. You continue Wednesday. Wednesday, remember, important day because I sent to you the test and the review. Thus we are doing something about the review, no? No, I don't know if it's too much or not, but don't worry too much because I will send a link of the video, not that video, you know, another video, okay, solving the entire review. And you watching? Any question? You have the email and communicate with me. Professor, do for me number something. Yeah, I do in 5 seconds. Yeah, I send to back. I don't understand. I send, you know, the screenshot, no the when the song explanation. Okay, guys. So now we finish. Let me see.
So you said send the test.
Wednesday attachment with the link. I send always for the connecting with the Skype. I send Wednesday, this Wednesday, the test number 3 plus another PDF document with the review package. Okay? But when I finish, as always, I send the link of the corresponding lecture plus another link special, que es the solution for the review. I try to do something, but I suppose I cannot finish. This is too long. Okay, guys, so I love you so much. Bye-bye. And Mia, stay. Gerani, izquierdo, stay, please. Stay. Wait for me. I go to the bathroom. Okay, I right back in, 1 minute. Alexa, enciende toda la luz.
Muy bien.
Okay, I am back. Mia and Geraine.
Yes,
Gracias.
Okay, listen to me. I am willing to help you, but you need your cooperation. Okay. Your situation is similar. So only me and half are doing the test number 1 online. But if you get the poor score, nothing, 18 points, it's nothing. So I can, so you let me know what is the best way for you. So you are pending test 1 and test 2 reading. You are aware that we have 5 chapters and each chapter contains 2 tests. 1 reading in paper and 1 online in Alex. The reading I send by email the copy in PDF. You solve it, and in the piece of paper you somehow convert to the electronic format, maybe picture or maybe PDF in a scanner, and you send me back the solution. You answer. Yeah, I grade that. Cool.
Yeah.
Yes.
And the online, no. In the online, I need to create extension because there's do. But no problem. I manipulate this. It's my software. As I manipulate, I create extension for you. I propose you do first the reading test. When you finish that, relax. No, not relax too much because you need to work fast. So now I create the extension online. Pero please, I would like from now you communicate with me frequently. Okay? Remember, this class online, you read the email every day, and you don't hesitate. I am your friend. Type, Professor, I need something. Boom. You send me to see. We negotiate. Okay, entonces now, Mia and Geraine, do you have in this moment the copy of the test number 1 and 2 reading? You have a copy or not yet?
Not yet.
Not yet.
Okay. So I will send particular for you. I will send test number 1 reading and test number 2 reading.
Perfect.
When you consider it acceptable due date for you? Next week?
This Friday?
This Friday is perfect.
I agree with her.
Okay, super. So this Friday is, by the way, is 20 something. Let me see. 20 what?
Yep.
Let me see the calendar. 24.
24.
24.
Yep.
Okay, so we are a deal. You send to me by email the solution or the answer for the test number 1 reading and test number 2 reading.
You got
the
it.
paper version, correct?
Right.
The one that you're going to send to email?
Yeah, by email. You send me by email. So the communication between us is email, guy.
Yeah.
Okay. So you're going to send the 1 and 2 test through email?
Yes.
Okay. Thank you so much.
I will say for you right now when the class is over.
Okay, perfect.
Okay. Thank you so much.
Oh, no. It's my pleasure. Don't say thank you. We negotiate that.
Yes.
Now, when I received the grade, immediately I posted the grade in Canva. And you receive the email and you see your grade.
Okay.
Entonces now, suppose que everything flow nice. No problema. Entonces now I activate for you maybe Friday. The test online. And what you consider is the due date for this test.
Okay.
Well, no, don't say nothing. Communicate by email.
Got it.
No problem.
Okay. Focus in the reading test, number 1 and number 2.
Yes.
Got it. Okay.
Super.
We'll get that done. Thank you so much.
No, I trust you.
See you Wednesday. Bye-bye.
Bye.
Thank you. Have a good night.